Section 8-4, Properties of Circles. Let's do a little review. We are going to figure out the supplementary answer to degrees in an angle. So let's remember what supplementary means. That means 180 degrees is our total. So if we know that one angle is 61, and we know that supplementary angles equal 180, we can find its partner. Let's think about complementary. Remember we said if they're complementary, you're right for each other. So they equal 90, which is the degrees in a right angle. If we know one measure is 19 degrees, we can figure out the other measure. And a little tricky one here, we want angles that are supplementary and congruent. Well, we remember that congruent means equal. So supplementary is a flat line, and if they are equal, I would have to cut it in half. So each of my angles would be what? Let's see if you're right. 119, 71, and 90 degrees for each. Today we're going to learn to identify parts of a circle and to find central angle measures. So we know that a circle is a set of all points in a plane that are the same distance from a central point. And boy, that was not the same distance from my central point, was it? Let's erase that and put a better central point there. How about here? So all the points on my circle are the same distance from my center. And we're going to name our center A. So this would be called circle A. So there's my circle. And we have different parts of a circle. The first one we're going to talk about is an arc. It's named by endpoints, but it stays on the circle. It's on the outside of the circle. It does not go into the circle. Our next one we're familiar with, it's our radius, and there's that central point which is ever so important to us. Our radius starts at the center and goes out to an endpoint, and there are an infinite number of radii I can draw on my circle. Diameter is again passing through the center, but it has to make sure to hit endpoint, center, endpoint, straight through, and it would of course cut my circle in half. And our last one you may not be familiar with is the chord. Notice the chord does not go through the center. It's an endpoint through the circle to an endpoint. Don't confuse chord with arc. Arc stays on the outside of the circle along the circle, not a straight line. Chord is a straight line that cuts into the circle. So let's name some parts of our circle. Radii. I always like to start at my center and find all the lines that start at my center and continue out. And those would be MN, MR, MQ, MO. Notice M was in every single answer. Well, if you remember, diameters go straight through, touching the center. So let's see what our diameters would be. NR, and of course QO, going through that center. Now chords are tricky. If the definition is from endpoint and then to another endpoint, in actuality, diameters are chords besides the ones that slice into the circle. So there are 4 chords because you must include the diameter. So pause this and see if you can name the radii, diameters, and chords. All right, welcome back. Let's see how well you did. Radii, starting at the center, GB, GA, GF, GD. Diameters from endpoint through center to endpoint, from endpoint through center to endpoint. Remember, those guys also get to be chords. So if you got your diameters, those are going to be your first set of chords, and then all the chords that slice into our circle. How'd you do? Next, we're going to do central angles of circles and sectors. The central angle is just the measure of our degrees. The sector is the actual slice of the pie. We're going to worry about the central angles right now and how to figure out degrees from knowing them. So let's start our first problem here. Oh, we also know and have to remember that there are 360 degrees in a circle. That's going to be very important in our problems. So our problem is that our circle graph shows our favorite types of muffins, and we want to find the central angle measure if we know a percent. So we're going to be concerned with blueberry muffins today, and that is my favorite, so I'm always concerned about blueberry muffins. So we know that blueberry muffins are taking up 40% of our survey. So let's make sure we understand our question. We want to find the measure central angle of our blueberry. So we know that the percent of people who like it are 40%, and an important thing is our circles always equal 360 degrees. So if there are 360 degrees in a circle and we want to know 40% of 360, that is our key phrase. And we always want to take our phrases and turn them into numbers and signs. 40% has been switched to 40.40 as a decimal. Of became our multiplication sign, and 360 got to stay the same. So if I multiply that out, I get 144 degrees. So my central angle measure is 144 degrees. And if we think about that, let's see if it makes sense. 40% is less than half, and we remember that a line is half, so that should be less than 180, and 144 is less than 180. All right, let's try it again, but this time our favorite is banana nut. Let's see what our problem is. All right, so we need to find the answer to the measure of the central angle for banana nut. We know that 35% of the people, their favorite is banana nut, and we also know that there are 360 degrees in every circle. So 360 degrees in a circle with a 35%. What do? Turn that into a problem with percent becoming decimal, of becoming multiply. And we solve it and get 126. So the central angle measure was 126 degrees. So 35% again is less than half, and we know half of our circle is 180 across our straight angle. So 126 is a reasonable answer. All right, let's take our quiz. Pause and see if you can tell me the radii, diameter, chords, and 8 equal sections. What would the central angle be? Pause now. All right, let's see how you did. Radii, always from B, the center of our circle, BA, BC. Diameters, only AC. Notice how EF did not hit that center, so you could not count that as a diameter. Our chords always include the diameter and anything that slices from one end to the other. So FE got to be a chord, but it wasn't a diameter. And the last one's a little tricky. Hope you got that one. 45 degrees. If we think about our circle and we cut it into 8 pieces, here's a right angle. So 2 of them make a right angle. So 90 divided by 2 would give me 45 degrees. Another way to think of it is, I know my circle has 360 degrees. If I divide that into 8 sections, I get 45 degrees. That was section 8-4, parts of a circle.